Okay, I had a question on, I think it was 4.63. And 4.63 is asking us, or describing a random number generator that has a range of numbers, uniform numbers between 0 and 2. So we're looking at a continuous random variable, which was defined as y, and the density curve of the random variable. So let's draw this out. So here's your random variable y. The density curve between 0 and 2, right, has what they said, a constant height. Okay, so that means we're looking at a uniform density curve. And then 0 elsewhere. So this is 0, and out here, everywhere else, the height is 0. So what do you know about density curves? So uniform density curve, the area underneath it has to equal 1. So if y goes between 0 and 2, that would mean that this height has to equal 1/2, because the area has to equal length times width, right? And if the length is specified to be between 0 and 2, then the width, the area has to equal 1, has to be 1/2. Okay, so this is the picture of the density curve. This was A. Right? What's the height of the density curve between 0 and 2, and draw it. So that's the answer for A. Now, using that density curve, we're asked to find the fact that the probability, using the fact that the probability is area under the curve, to find, this is B, the probability that y is less than or equal to 1.6. So let's draw it out. So 1.6 is right about here. So I want to find the area of the, hold on, I'm going to pause for a minute here. Sorry for the interruption. So remember the height is 1/2. This length is 1.6, right, because it goes from 0 to 1.6. So that distance is 1.6. So the probability of y being less than 1.6 is the area of that rectangle, which is height of 1/2, and the length, or the width, whichever way you look at it, is 1.6. So the area, which is the probability, is equal to 0.8. So let's look at the next question, which asks for the probability that the random variable is between 0.5 and 1.7. So let's draw it out. And here it goes from 0 to 2, but I'm looking at the probability between 0.5 and 1.7. Grab another color here again. So I'm looking at finding the area, because probability is area under the curve, between 0.5 and 0.7. Well, the area of that is equal to 1/2 times this distance is 1.7 minus 0.5, and computing that area, you come out with 0.6. So that probability is equal to 0.6. Let's look at the next one. D, you're asked to find the probability that y is greater than or equal to 0.95. And remember, just like the normal distribution, you want to draw a picture. So we're going to draw a picture. Here's your density curve. This is y. Right, that's 2, that's 0, that's 1/2. I should put that up there too. And I'm after, here's 0.95. Grab another color. I'm after this area. And that area is equal to 1/2 times 2 minus 0.95, which equals 0.525, right? Because I'm trying to find this distance, and that distance is 2 minus 0.95. So that probability is 0.525. Okay, so here the information that you got from the word problem just basically states that it's a uniform density distribution. So as soon as you see uniform, the height of the distribution is constant, and that's the key. So that defines a rectangle for you. Hope that helps.